Okay, so let's quickly, I'll do it over here. Let's quickly do an example. Okay, so we'll do a half plus a quarter. A half plus a quarter. So the denominators are different in this case, right? How do I change one or both of these fractions so they'll have the same denominator? Anyone want to suggest? Brandon?
You times the bottom by 2, you times the top by 2.
Okay, so if you have a look at this guy, right? 2 and 4, the difference is, well, 4's double that, right? So if I take this, I multiply that one by 2, but if I change the top, I better change the bottom as well, right? Because otherwise it would actually be a different fraction. So I've multiplied the top and the bottom by 2. That gives me 2 over 4. Okay, now do you remember, just before we actually say, add them together, a half and 2 quarters. Right? These guys are linked. Does anyone remember from last year, what is it called when really it's the same fraction, but it's like kind of looks different? Wearing different clothes. It's the same size. You don't remember? Starts with an E. E?
Oh,
yeah, equivalent fractions. Very good. You just needed a bit of a nudge, right? Equivalent fractions. So if you were to have 2 pizzas, one of them was just sliced down the middle, and the other one was in quarters, okay? It wouldn't matter whether you took half of the pizza or 2 quarters of the pizza. It's the same thing. It's equivalent, okay? And that's why we can do this. Now they're on the same denominator. What can I do with these guys now? What can I do? I can, Brandon.
Just add the 2.
Good. Now, be careful, by the way. Be really, really careful. We just add them, but what we add is the numerators. It's the numerators, not the denominators. So I'm going to get 2 plus 1. There's the numerators. And then that denominator just stays the same. Okay. Now, the way you can remember this is 2 ways. The first way is, remember, what is the denominator and what is the numerator? The denominator is the size of the pieces, right? How big are the pieces? So if it's 100, the pieces are very, very tiny. There's going to be 100 little pieces. The numerator is how many pieces do you have? So when you add 2 things, right, the sizes stay the same, okay? For instance, if I put together, like just to give a crude example, if I put together, here we go, okay. So if I put together one green marker plus another green marker, okay, they don't become like really, really green markers. They still stay, they still stay the same color. Right? Yeah, very good. Okay. Now, in the same way, when you add 2 fractions together, the fractions don't change in size, but you add together the quantity, and that's the numerator. Okay. So 2 plus 1, of course, is just 3. I said that's one way to remember it. The other way is just to think, it can get a bit ridiculous if you added the numerator and the denominator. Think about this guy. A half plus a half. We all know what a half plus a half is. It's just 1, right? It's just you put the 2 halves together and you get the whole back. But what would happen if I added the numerators and the denominators? You'd add the numerators and get 2, and then you'd add the denominators and you get 4. But hold on a second. We just said that 2 over 4 and 1/2 are the same. And I'm pretty sure that a half plus a half isn't a half. That's like my older brother trying to give me a bad deal on like, yeah, sure, here's how much you get. This is your share. I'm like, I think I've lost something here. So you don't add the denominators and the numerators. What would the right answer be? How do I get to 1? Yeah.
It should like times the...
Okay, we're not doing any multiplication just yet, except for changing equivalent fractions, right? I'm going to add the numerators. That'll be 1 plus 1. And the denominator stays the same, over 2. Does that make sense? Yeah. Okay, so make the denominators identical. Okay, let's do a second example, and you'll see another useful thing that you can do. Okay. So if I say 3 quarters plus 1 and 2 fifths. Okay. Now this is a bit trickier, right? Of course, I want to do this. I want to make the denominators identical. But in addition to that, like, this is quarters, this is fifths. Even if I got them on the same denominators, like this 1 and 2 fifths is a bit awkward to work with, okay? So I'm going to get rid of mixed numerals where I can. Remember, mixed numerals are just another way of writing improper fractions, okay? So how would we write 1 and 2 fifths as an improper fraction rather than a mixed numeral, as it is right now? What do you reckon? Rachel, what do you think?
7 and...
Okay, it's 7 over 5. Now, just before I get to 7 over 5, because some of you see that immediately, and that's great, but I know I look at this and I sometimes muck up this conversion process, okay? Here's how I would think about it. Remember I said to you this is 1 and 2/5? 1 and 2/5? So this is really 1 and 2/5. Do you agree with that? Like I've literally just put the and in there, okay? Now here, this 1, I can replace it with, like I'm in fifths over here, right? So I can replace that 1 with 5 over 5. Do you see that? Like that's the equivalent fraction to 1. And now you can see 5 plus 2, that's what gives you the 7. That's where the 7 comes from, okay? Any questions on that conversion process? Is that okay? To get rid of mixed numerals, this is what we do. Now we've got an improper fraction, okay? Now that that's in that state, I can do this, make the denominators identical. William, why don't you give me a suggestion? What could I do to each of these fractions? I might give us a little more
Times
space.
4 by 5, times 3 by 4, times 5. Like, search for the lowest common multiple.
Okay, very good. Lowest common multiple. We want the lowest common multiple of both denominators, right? The lowest number, the smallest number I can think of that you can divide into 4 and 5 is 20. Very good. So to get to that, I'll multiply this one by 5 over 5, and I'll multiply this one by 4 over 4. Okay, so you're going to get 20s there and 20s there. Does that make sense? Okay, so let's quickly do that. 15, 28. Okay, so now they're the same denominator, and now we're good to go. I can just add the numerators and the denominator stays put. Okay, 15 plus 28. Okay, so we can see what's going on there. 15 plus 28. 15 plus 28. 43 over 20. And you're finished. Okay, you're finished. You could, if you liked, and sometimes the question will ask you to do this, but I haven't. You could, see how it started with mixed numerals, you might like to put it back as a mixed numeral. That might be useful to you, okay? So if I wanted to write this as a mixed numeral, how do I put it back? How do I do it in reverse? Yeah, Brandon, what do you suggest?
Divide 20 by 43.
Yeah.
Which is 2 and 0.
Very good. I want to think about how many 20s can I fit in 43? Or whatever that denominator is. Like if the denominator was 7 or 18, you think, how many of those do I fit in here? And the answer is 2, right? Once you take out that, 2 20s are 40, so you get left with the 3. Done.